We're going to solve problem number 2b from the same worksheet. I just did 2a, so now I'm going to do 2b. I'm going to use the information from A to help solve for B. B is asking, says, how much work could be done by this much electric charge? So we solve for charge, and the charge from part A is 9.6 times 10 to the negative fifth coulombs, and I'm going to use that and the voltage to solve for the work. So let's go to our little sketch pad. Alright. So, like I was saying before, we're going to solve problem number 2, part B. And it says here, it says that, again, I won't write down the number of electrons we have, but it says that the voltage in this problem was 12 volts. And the charge from part A we received was 9.6 times 10 to the negative fifth coulombs. Alright, so now it wants to know how much work. How much work could be done. So this actual charge could perform some work. And that's what we want to know is like, so we have a voltage and a charge, how much work, and we said before that work is energy. It is energy. And anytime we look at anything that's related to energy, we can always go back to work, and they all have the same units, joules, because they are the same. They're just transferring. Energy transfers from one to another. So make sure that you realize that, and especially for the test tomorrow. Okay, so let's get started. So where I get going, if we're solving for energy, and what I have is I have 12 volts, and I have 9.6 times 10 to the negative fifth coulombs. Just knowing that I have those two things are in a relationship with work. And so what I look at is voltage. Voltage, if you look at it, remember what we said before, electric potential energy. Electric potential energy divided by the charge. And if we keep with our same topic here and we say that work is energy, whatever work is done is going to need some energy, it's going to build some energy as well, we can substitute it in right here. So work divided by charge. Okay, so if I'm solving for work, I'm going to need to multiply charge on both sides. And that's what happens, is that I'm going to end up multiplying the right side by my charge and the left side over here by charge. So here's what it looks like. I'm going to substitute in Q for charge all over here. I'm going to substitute in Q for charge. So what it looks like is that this charge cancels out here, and then I'm left with work is equal to voltage times charge. This piece right here, this is really important. So it looks like this. Work is going to be equal to voltage times the charge. And so now I can substitute in, because I have those things. I have 12 volts, and I'm going to multiply that by 9.6 times 10 to the negative fifth coulombs. And if I multiply this out on my calculator, I end up getting 1.15 times 10 to the negative third. 1.15 times 10 to the negative third joules. And remember, a volt is a joules per coulomb, and so the coulombs will cancel out with that part of voltage and leaving us with joules. And so joules being the unit of work, we know we're on the right track. Circle your answer, and we're done.